right, with no further ado, let's get into today's lesson. All right, let's talk about probability. Okay, so throughout this lesson, we're going to be using the usual probability examples that we have. What happens if you flip a coin? What happens if you roll a dice? But before we do that, we're going to be looking at what probability actually means to us in real life. Okay, I think I'm going to use an easier example than Apple because it's going to confuse a lot of people and I don't want to leave anybody behind. All right, let's say as Watobe, we start a company where we're going to sell hats, right? Now, these are really cool hats, guys. Don't knock hats before you try them. Okay, we're going to name them Watobe. And one day, once we start this company starts taking off. It takes off. And we get very, very popular. Like, we get supreme popular. You know, like, remember, guys, when Supreme came out, everybody wanted something that had Supreme written on it. Even Louis Vuitton did something with Supreme. It was a big deal, right? So now Watobe is taking over. And we're so popular, we start attracting investors. So now people are like, okay, give us a bit of your company and we will then help you guys grow your business. And we do. We start growing our business and our business gets so big that, oh, I think I may be frozen. Guys, can you hear and see me? Just give me, okay, yes, you can. All right, so our business goes so big that we decide that we are going to start selling shares for Watobe hats or Watobe caps on the stock market. Do we know what the stock market is? Who knows what the stock market is? Let me know in the chat. Peeps, do we know what the stock market is? Yes or no? Namisile says nope. Okay, some people say yes, some people say no. Okay, so the stock market, correct, Tiana, that's it. It's where people kind of sell shares. So if you decided today that you wanted to own shares in Coca-Cola, you go to the stock market and you can buy shares for Coca-Cola, a market filled with stock. Yes, Zizanele, yes, correct. Okay, then now you decide you want to buy shares at Coca-Cola. Now, what that means is you are now a part owner of Coca-Cola. Or in this case, people start buying shares for Watobe hats. High close bracket. Okay. People start buying shares in Watobe hats, right? So now you are now a part owner of Watobe. So let's say, for instance, Watobe hats makes their hats here in South Africa at a factory. We're making our hats at a factory, right? What is going to happen to our profit if our factory goes on strike? What do you think is going to happen to our profit if our factory decides to go on strike? Yes, Mara.
Ma'am, won't the profit like decrease?
Absolutely, our profit will decrease, right? But what happens, let's say, for instance, Watobe hats, let's say, for instance, who's the most popular rapper out there? Drake. Let's say Drake in his next video is wearing a Watobe hat, right? What do you think is going to happen to our stock or our profit? You can answer, Mara, you're unmuted. Hi, Mara. Did somebody just say, who's Drake?
Ma'am, since Drake is gonna
sure, okay. You're breaking up.
Hi, ma'am.
Hello. Okay. Okay. So I think what Mara's saying is, since Drake is so popular, the chances of our CR7 is Cristiano Ronaldo's teacher now. Even I know that. I'm cool. Hey, I'm with the kids. That's his number. His number 7 and Cristiano Ronaldo.
I know that, but I'm asking him because he'll ask about Drake.
Oh, okay. I see what you did there. Yeah. Okay. It will increase because exactly up here. The price of our stocks will increase. So what we can do, guys, is we can use these things. Remember, Watobe is just a made up situation, right? We can use this. We can use these things to make predictions. So when they ask us, what is probability? What is probability? Probability is actually a calculated prediction. Okay, it's a calculated prediction. So we know we're predicting if our factory goes on strike, the chances are we won't have any hats and therefore our profit will decrease. But if we happen to have, I don't know, Nasty C or I don't know, Doja Cat, somebody famous wearing one of our hats in a music video, then we can predict the probability of our profit increasing is very, very high, right? So we know that we can predict things by using the probability, but we're going to be looking at the probability of things that are somewhat plus minus in our control. Now, give me a thumbs up if the idea of a probability makes sense. A probability is a calculated prediction. Hi, Queen Jasmine.
Hi, how are you doing today?
You're doing probability. Okay.
One of the rules being kind of broken, the current rule, because Drake is actually what you call it, male duck, as well as the rapper.
Oh, I didn't mean it like that. I didn't. But you see now, Queen Jasmine, here you are coming with cringe. I meant the rapper. See, no, you can't punish me. I meant the rapper, Queen Jasmine. No, wait. That was my joke for the day.
It's okay. It's okay. It's possible.
Okay. That was my one joke for the day. No more. No more. Okay, sure, guys, I've been caught by the class monitor. I need to watch myself. Okay. Asi says, do our predictions have to be accurate or theoretical? Like we calculate the predictions, but does it have to be accurate or theoretical? Now, Asi, what you have just said is basically the crux of what we're going to be learning about today. And I see somebody asking me, why are we looking at this kind of thing? Okay, so if any of you have ever been thinking of a career in things like actuarial sciences, or you're thinking of going into data science, or you're going into stock brokering, calculating the probability of something happening is how people make money on the stock market. That's how they figure out, should I buy shares in Watobe or not? Should I buy shares in Coca-Cola or not? What is happening at Coca-Cola at the moment? What is the probability that if I buy shares at Apple, the shares will increase? I will make more money. So that's the reason why we look at the probability of things, because it helps us to make decisions for the future. Now, let me ask a simple question. Do we actually know what is going to be happening in the future? Do we know? Yes or no? Do we know? No, absolutely not. We don't actually know what's going to be happening in the future. That's why we call it a calculated prediction. It's a prediction. We're never really going to know what's going to happen. Maybe, Samuel, that's also a prediction. Flying cars. Like, let's say, for instance, let's take what Samuel's saying now. If, I almost said Nikola Tesla. What's the guy's name? The one who owns Tesla again. Yes, correct, Danvir. It's like an estimate. That's it. That's his name, Elon Musk. Now, if Elon Musk starts saying, I'm going to start building flying cars, right? Now, we can think of all the other technological things that Elon Musk has done. Things like SpaceX, things like Tesla. So we know the probability of him succeeding at making a flying car, very high. Okay, it's very likely that he would make one. So it would be good for us to invest in Tesla, because if he's starting to make, if he's starting to think about making flying cars, and flying cars are things that are going to be needed, it's good for us to invest now while the stocks are still cheap, because by the time the flying car actually comes out, buying Tesla shares is going to be very expensive. Okay, so those are the kinds of things that people do when they study actuarial science and data science and stock markets. All right, okay, so, but again, guys, we don't actually know what is going to happen. We don't know what is going to happen. That is why we call it a theoretical probability. It's only theoretical because we don't know that it's actually going to happen. It is a calculated guess. All right, so if you are taking notes, here's the one thing that we're going to look at. We're going to look at probability being described in 3 ways. First way is that we can look at the probability of something being calculated in percentage. Okay, so what is the chance that you will win the lotto? 0.0002%. Okay, not a very high, not very high probability, right? What is the probability that it will rain? It's a 50-50 chance. So we'll say half a chance. It either will or it won't. So we can either write the probability as a percentage, we can write it as 1/2, or we can write it as 0.5, as a number out of 1. Okay, one of these things, I see if you do win the lotto, then you need to remember that 100% I'm your best friend. Ne? So what is the probability of Teacher Coco being your best friend if you win the lotto? 100%. Don't forget. Okay. All right. But if we have to describe things, we can say here, right, that if we have a 0% chance of something happening, we can say that it's almost never going to happen, or it's very unlikely. It's very unlikely that it's going to happen, right? Now, if it's a 50-50 chance or a half chance that something will happen, we can say that it's equally likely or unlikely. It's equally likely and unlikely. Now, if there's a 100% chance of something happening, 100% chance or a full chance, a full 1 chance of something happening, then we're going to say that it's very likely, right? Now, if it's somewhere in between, equally likely or unlikely, we can say that it's likely that something like that would happen. Likely, and if it's like in between 0 and 50, we can say that it's unlikely. Okay, so we can think of this particular idea as what the probability of something is going to happen. So we're going to describe it in words. We're going to describe it as a percentage, as a fraction, or as a decimal. And we're also going to use our words to describe it. Now, I want you guys to look at these 5 ideas over here. Okay, tell me what the probability is. It is almost never, or very unlikely, unlikely, equally unlikely, likely, or very likely for these 5. Once you are done answering these for yourself, I want you to put your favorite emoji in the chat for me, please. Okay. Sure, Chloe's already done, and so is Anha. And there were only 3 likelies. Let me see. Very unlikely, likely, equally likely and unlikely, unlikely and very unlikely. It's a lot. I know it's a lot. Yeah. Akwando always with the food baby. I appreciate the food baby. Samuel, you need to practice how to move that pen, not just your feet around a ball. All right, peeps. Okay, let's look at this. All right, so what is the, if you looked at the weather and they said that there's a 90% chance of rain tomorrow, is that equally likely, unlikely, likely, very likely, unlikely? Which one is it? What do we think? Good. I would think if you said likely or very likely, I agree with you. Likely or very likely. Right, likely or very likely. I'll take both of those answers. Okay, what is the probability of a tsunami in Johannesburg? Yes, Namisile.
I was gonna comment about A.
Yes. What were you gonna say?
I said equally likely and unlikely because let's take the seasons into consideration. It's winter and it hardly rains in winter. Maybe if it was summer or spring, I would say likely, very likely. But in the season it's like unlikely.
Yeah. Okay, I agree with you. I agree with you there. So if we think about the fact that winter is very dry and it may not, it may not rain, I'm gonna accept your answer. Absolutely, equally likely or unlikely. Agreed. Okay, I agree. And you're thinking way further than I was. I was just like, is it gonna rain? Is it not? Yeah. Okay, I didn't go that far, but I agree with you on that one. Nice one. Okay, well, I'll take any three of those answers. Okay. Thanks, Namisile. Nice one. Yeah, maybe climate change, maybe. See, Teacher Nels is the economy, like she's the environmental scientist. So she's also thinking about global warming could also make it rain. You guys are too deep, guys. It's a maths class, not a philosophy class. Please, Tiana, what's up?
Ma'am, the second one say a tsunami in Johannesburg. Ma'am, I said equally likely and unlikely because it's just South Africa. Anything happens here, like the earthquake that wasn't the earthquake, the road in Joburg that went halfway. It's equally likely and unlikely.
You know what? I kind of, at this point, I think I'm going to agree with you because we've had snow this year. We've had an earthquake this year. We've had pipes burst, like all streets just boom, up into the air. You know what? I kind of agree.
Equally likely and unlikely, babe. Like it's possible.
Yeah, you know what? I agree. But I said unlikely because Johannesburg is landlocked. Okay. I said unlikely because it's landlocked. And mostly tsunamis happen in places where there's like a sea coast. You know what I mean? So I said unlikely. But if you said equally likely and unlikely, I'm going to take that because clearly South Africa is on some sort of witchcraft of late. And there are so many things happening. So many things happening in this country right now. We could never be sure. Okay, I said unlikely. I also will accept very unlikely. Okay, unlikely, very unlikely, or equally likely. Equally likely and unlikely, I will agree. Okay, Offensa and Chloe with your It's Giving Zimbabwe. The class monitor is watching. All right. I know everything is possible in this country. All right. Tiana, your hand is still up, my sweetie. Do you have something else to say? All right. Namisile, what's up?
I was gonna give the answer for C.
Okay, C. What is the probability of you turning into a frog? No, I know where this is going.
Like almost never, but obviously we have a Princess Tiana here, so 50-50.
Almost never or 50. I knew this was gonna come up. I knew somebody was gonna say South Africa. I knew somebody would say witchcraft. Look now, offensive. Ufense and Anna are on some. People fly at night in South Africa, ma'am. I knew this would happen. But I would say almost never or very unlikely. Y'all are wild. I can't believe you guys. But thanks, Namisile. Okay, I say almost never. Yewana Yusuf, I'm from Limpopo. Watch your words. Watch your words. Yeah. Okay. Anna, be careful. All right. Okay, so it says here, throwing a dice and having it land on an even number. Let's think about that. This one is probably an easy one. Good, it's equally likely or unlikely. Okay, because there are 3 odd numbers and 3 even numbers. So it's equally likely or unlikely. Okay. All right. Then it says throwing a dice and having it land on 1. What do we think about E, guys? Good. Yes, Danvir, beautiful. It's we could say equally likely or unlikely, or we can say, I'm going to say unlikely for this one. If you said equally likely or unlikely, I agree. But it's a 1 in 6 chance.
But
It's
no,
a 1
you
in
can't
6.
say equally likely.
Okay.
Maybe likely or unlikely.
Yes, but I think the reason they're saying that, teacher Nels, is because you're rolling the dice. So you're either going to roll the dice or you're not. And I can see where somebody in their mind could be like, I'm either going to get a 1 or I'm not going to get a 1.
But there's so many options that you can get.
You know what I mean? Yeah,
Yeah,
I think
it's
this
more
one
than 2 options. At least if it were 2 options, then you can say equally likely. But we have more
but
than
I think in
2
this
options.
case, I think in this case it should be unlikely. But I can see, because we're being very philosophical today, I can see why somebody would pick a different answer. But in this case, I'm thinking it's probably unlikely. Okay. Akwando, that is a very apt statement, because we're going to be talking a little bit more about that today. All right, let's talk a little bit more about the definitions that we've just looked at. All right, well, we skipped over them, but we're going to talk about them right now. Let's talk about these particular things here. All right, so a sample space is always all the possible outcomes. I'm going to write here, all possible outcomes that we could get. Okay, possible outcomes of an event. Right, all possible outcomes before we even do anything. If you're taking notes, this would probably be the thing that you need to write down. So let's say, for instance, we do roll a dice. If we do roll a dice, our sample space S is then going to yield 6 possible outcomes. We're either going to roll a 1 or a 2 or a 3, correct, Akwan, Apiwe, or a 4, or a 5, or a 6. That's it, Luandile. We're going to either roll either of these. So this is, no worries, Zisanela, I'm not even sure what that is, but you can come back quickly. All right, this is our sample space. Our sample space is what we're possibly going to have as an example. Yes, correct, Samuel, is probability. Now, let's say, for instance, we flip a coin. What is our sample space going to be? And I know that many of you are going to say our sample space is going to be 1 or 2. Think about it very carefully. What is our sample space going to be? Correct. It's not going to be the number of outcomes we have. Oh, and there goes Danvir saying that one thing that was also said in the other class. Our example is going to be heads or tails, right? And I see Danvir also saying, and the side, yes, the side. But remember, what we're talking about isn't always going to be, oh, Samuel, we do Venn diagrams on Wednesday. What we're talking about, if we add a side, the things that we're going to be talking about here, guys, is things that have an equal probability of happening. So we're going to stick to just heads and tails. Okay, heads or tails. Right. Tiana, what's up?
Babe, I have a question. So
Yes.
the teacher said sample space is all the numbers together. So now we counted the numbers. Like, then you count all the numbers and you see how much numbers is there. Like, there's 6 numbers there.
There is 6
I'm not
numbers,
sure.
but but it's because on a dice, or I could even write it like this instead. I could say, this is the first side of my dice with a 1 on it. This is the second side of my dice with a 2 on it. Like
So,
that. I could
so what is it actually? So is it all the numbers?
no, it's the
possible.
number of sides. The number of sides.
Okay.
Just the number of sides. Not how many, not like what number do we get? What number do we get on that side? We get a 3 on this side, we get a 4 on this one side, we get a 5 on the other side, and we get a 6 on the other side. Okay. So it's not really about how many we have. Namisile, you're starting, but it's about what we have on each side. We have 6 sides of a dice, and the numbers, these are the numbers that show up on each of those sides. Let's think about the sample space of a deck of cards. Let's think of a deck of cards. Okay, now deck of cards, there are 52 cards, so we're not going to name them all, but we need to be very mindful of the fact that we get an ace of spades. And Namisile, don't judge my throat. Right, we get a 2 of spades. Right, and then we get a 3 of hearts. And we get a king of diamonds. Right, this is going to be our sample space. Not that we have 52 cards, that we have 52 different cards in a deck of cards. Give me a thumbs up if the sample space makes sense. Offensive. You know what? Never mind. Actually, you know what? Never mind. I knew you guys would judge me for my drawing. I just knew. Okay, excellent. All right. So there's a difference between how many things we have and what those things actually are. Okay. Okay, Namisile, where did I lose you? You need to tell me where I lost you. Hi, Namisile.
Hi. You lost me at the deck of cards.
Okay, so how many cards are there in a deck, in a standard deck?
Yo.
There are 52 cards, right? There are 52 cards to choose from, but those 52 cards don't have the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. Do they have the numbers on them? Not particularly. Some of them do, but it's always the ace of spades or the ace of clubs or the ace of hearts, right? So they're very, very specific, and that's what I'm trying to get at. Okay, that the cards themselves are specific, just like your sample space for the dice. The dice has 6 sides, but on one of the sides there is a 3. On the other side, there is a 5. There are 5 dots. Okay. All right.
Okay,
so we're being very specific. Am I making sense?
Yes, thank you.
Good. You're very welcome, my sweetie. Okay. I saw somebody else also say, ma'am, please explain. I hope this explained this for you. Courtney, are you understanding what I mean by sample space? Good. All right. Excellent. All right. So the experiment is what we actually do, what we do. Okay. What we do. And by that, what I mean is, do we roll a dice? Rolling a dice, that is what we do, right? Do we flip a coin? Correct. So that's it. Do we flip a coin, or do we pick a card? Do we pick a card? Right, that is the experiment as well. Okay, correct. Who said that? Probability will show you that you should stay away from gambling. Correct. Yeah, okay. Now, the outcome is what actually happens, right? What actually happens is going to be the outcome, right? But remember, we're going to choose in this case what we want to happen. Right, what actually happens, or what we want to happen. Let's say, for instance, we want to calculate the probability of rolling a 3. The experiment was to roll the dice, and the outcome was the 3. How likely was it that we got a 3? And the probability is what we expect what we expect, or the likelihood of what we expect to happen, the likelihood of it. Okay, the likelihood of what we expect to happen. All right. Okay, so these are the things that we're going to be using, and I know that some of your teachers are going to use the definition. So we're going to say, what is the probability of our experiment? Now, if we're looking at the probability of our experiment, we're going to consider the number of the experiment that we're going to get out versus the number of the sample space, number of sample space that we have. Let's look at an easy example, right? If I flip a coin, my sample space is either heads or tails. Now, what is the probability that I will flip the coin and it will land on tails? Now, the number of experiments that we've done is 1, right? We knew that we would get 1 heads out of the sample space, which is 2, right? Yes, Mara, which is the same as 0.5 or 50%. Yes, Mara.
Ma'am.
Yes.
Can you please explain what you just like started with, because I'm having negative connections.
Okay, all right. Okay, I want you to look at this formula that I've written over here, right? I want you to think for me, Mara. Let's say, for instance, our sample space is the dice, right? How many possible outcomes can I get for a dice? What are the different possibilities that I could get if I rolled a dice?
You could get an even number.
Good, you could get an even number. You could get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. Agreed?
Yeah. Yes.
Good. So we have 6 options in our sample space. Now, if I said to you, Mara, what is the probability of me landing on a 3? How many 3s do I have on my dice?
1.
1. Good. So the probability of me throwing a 3 is going to be 1 out of the 6 options that I have. Okay. Am I making sense?
Yes.
Okay, cool. And that's as far as we've gotten. We haven't gotten any further than that. Okay.
Okay. Thank you.
You're very welcome. Excellent. All right. Okay, so let's look at this over here. Now, remember, guys, we're calculating the theoretical probability. We actually haven't calculated for it yet. Okay, Abiani, I need you to put your hand up for me. Remember? Okay, sorry. And I don't know how I cut this off. This was supposed to say theoretical probability is a prediction. I don't know what happened there. Right, theoretical probability is a prediction. Yes, Tiana.
Babe, so what
Yes.
the question before this, so if there was 2 3s on the dice, like just an example, if there were 2 3s on the dice, was it going to be 2/6?
Correct, 100%. Okay, so we need to count how many of something we have, and I'm going to show you another example now. All right, let's look at this one over here. Now we're throwing a dice, guys. In these examples, we're looking at for the theoretical probability, and we're throwing a dice. So our sample space is going to be the side 1 or 2 or 3 or 4 or 5 or 6. Those of you who are with me, please answer the A, B, and C here. Answer these 3 questions. Okay, pop your favorite emoji in the chat while I speak to Abiani. Abiani, what's up?
Ma'am.
Hi, my sweetie.
How are you?
I'm good, thank you. What's up?
I'm good. So, ma'am, on the equation, ma'am, the formula, can you please just like elaborate for me what it means?
Okay.
Because I don't understand.
Okay, so the probability of an event happening, right? P stands for probability, right?
Yes.
That is going to equal to the number of outcomes we expect from our experiment over the number of events that will happen over the number in our sample space. So N is the
E for?
E stands for event. Okay, event.
Event
right?
as in
Throwing a
What?
dice, an event.
Okay, so the example that you gave me, you say the sample equals to H1 or T, H1T.
Yes. Okay.
And
So our sample space, if we flip a coin, right, we know we're either going to get heads or we're going to get tails.
yes,
Right. So now this N stands for number. Okay. How many number, like what is the number of outcomes that I can get? Heads or tails gives us how many options?
true.
2 options, correct. So the probability of any event involving heads or tails will give me anything over the 2, right? Now, what is the probability that I will flip a coin and it will land on heads? How many times can I land on heads?
1. Because we have
Once.
1 here.
So my probability of throwing heads is 1 out of the 2 options that I have.
So if it was a dice and the question says probability of landing on 3, it was going to be 1/6.
Correct. Yes, 1/6, because I only have 3 on one side of my dice, but I have 6 possible outcomes.
Oh,
Okay. Is it clicking?
okay. Yeah,
Okay.
it's
Look at this
clicking.
next question over here. Here, this one says, if I throw a dice, what is the probability of it landing on 2? Can you answer this question for me?
It's 1/6.
Correct. 1/6. Well done. That's it.
Oh,
All right.
okay. I understand.
It's
Thank
not
you.
as deep as we're thinking it is. It's quite easy, isn't it?
Yes, thank you.
You're very welcome, my sweetie. All right. Okay. So let's look at this next one. Abian has very kindly answered the first one for us. Let's look at B. Guys, pop your answers in the chat. What is the probability of throwing a dice and have it land on an even number? What is the probability of us getting an even number? Correct, Danveer. Good. It's going to be 3/6 because there are 3 even numbers, right? I have a 2, a 4, or a 6, but we cannot leave it there. We need to simplify as far as we possibly can. Okay. No worries, Asbonke. I'm glad you understand. Okay. So our answer must be 1/2, or our answer must be 0,5 or 50%. Either of those will suffice. Okay. Now, let's look at C. Throwing a dice and have it land on 7. Okay, good. We're all together here. It's 0. The probability of landing on a 7 on a 6-sided dice is 0 because that side doesn't exist. So 0%. Okay. Oh, it's the same. Okay. So normally we say 1 dice and 2 die. Okay, no, dice is singular and die is plural. Okay, so other way around. I know that's English. English is not Englishing. Right, 1 dice, 2 dice. Oh, 2 die, sorry. Yes, 1 dice, 2 die. Yes, yes, Tiana. I feel like this is an English lesson, a geography lesson, a philosophy lesson instead of a math lesson. Yes, Tiana.
But I had my teacher say it's 1 die.
No, it's 1 dice.
Yeah, even Google
Die.
say it's 1 die and 2
I
dice.
don't know how, guys. Yeah, hey.
Let's not digress. Okay, let's not digress.
English never
Danveer, that was very cringy. That was very punny and cringy. Okay, hey guys, all I'm going to say is that English is not my mother tongue. Okay, guys, I don't know. Check Google. I don't know. All right. As far as I've heard, it's 1 dice, 2 die. Maybe it's 1 die, 2 dice. Hey, guys, I don't know. Okay, let's continue. All right. I know, Hope. Me too. I'm just going to say 1 dice, 2 dices. Carry on with life. Okay. All right. Now it says flipping a coin, right? So I know that flipping a coin, my sample space when I flip a coin is going to be 2 options. I'm going to have heads or tails. So flipping a coin and having it land on heads, the probability of getting heads is going to be 1 over my 2 options. Okay. Now, what about flipping a coin and having it land on its side? Good. In this case, we're going to say 0. Remember, it's a theoretical probability. Okay, to have it land on its side, we're going to say 0/2. I understand that somebody is going to tell me, yeah, but ma'am, it could land in the crack and it could stand up straight. I get that. But we understand that, if we're looking at a fair coin, one that isn't going to fall through a crack, the chances of it landing on its side, very minuscule. Okay, and it's not a fair probability in that case. All right. Okay, now let's talk about relative frequency. I'm going to give everybody 1 minute to run and grab any coin they can find. Okay. Run and grab a coin. I'm going to grab my wallet quickly. Cool. All right. So I've got my 5 Rand coin over here. I hope you guys also have your coins. If you don't, let's talk about this. All right. So we said, if we had to calculate for the probability of flipping a coin, we only have 2 options in our sample space. Our sample space will give us 2 options. That's fine. Denver, we'll take them. I also have a few US quarters in my house as well. Right. So heads or tails. Right. Now, what is going to happen? What is going to happen if I throw this coin, or what is the probability of me getting heads? We know that the probability is going to be 1/2. But what happens if I throw this coin 10 times, times 10? What is the probability of me landing on heads if I throw the coin 10 times? Good, it's going to be 50% either way, because the probability of getting heads is still going to be 1/2. I'm just going to get 5 out of those 10 times, it's still going to be 1/2. But remember, guys, remember that what we are doing here is we are looking, when we look at the probability, we are thinking of the theoretical probability. This is what we think is going to happen. Okay, this is what we're predicting is going to happen. So here's what we're going to do. Using a coin of your own, you're going to flip the coin 10 times and you're going to record what you actually got. All right, grab your coin. Everybody's got 2 minutes. Flip your coin 10 times, record your answers. Okay, I'm going to start my flip. Okay. It's 1, 2, 3. That's okay, Kensani, just wait for us to finish and then we'll talk. 4. 5. 6. Akwando, just choose one. Choose one. Okay. Choose any side to be heads and the other side to be tails. Okay. Seven. 8. That's perfectly fine. That's perfectly fine. Tarika. 9. Let me see. Flip last time for me. 10 heads. All right. Okay. So now we're going to look at this, right? Look at how many times you've gotten each of these, right? Now, our prediction was that we were going to get heads 5 times and we were going to get tails 5 times. Is that the actual outcome? Does that match our outcome? Did I flip 11 times? Oh, sorry, offensive. Let me count. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. I did. Right. No. Okay. For some of us, it's going to be correct. But for some of us, not. It's not going to be. Okay. But I want you guys to notice something. If I had flipped my coin once, okay, what is the probability that you will get heads? We said that's 1/2. Now, I want everybody to flip your coin once. Give me a thumbs up if you actually do get heads, and give me a thumbs down if you didn't. Flip your coin once. Tell me if you get heads. No, I didn't. 0. I didn't get heads. I got tails. How many of you guys got heads? Right. Okay. Now, if we think about this, our probability when we throw the coin once, the outcome either becomes 0, which means we didn't get heads, or it becomes 1, we did. But the more times we do it, the more times we flip the coin, the more likely our probability becomes true. Okay. Because if I have to count the number of times we've done this, 1, 2, or let me count the number of times I got heads. How many times did I get heads here? 1, 2, 3, 4. I only got heads 4 times. That is 4 out of 10. That is a 40% chance. When I throw my coin, or when I flip my coin 10 times, I get a 40% chance. When I flip my coin once, I have a 0% chance. Okay, because I didn't even get any chance to prove that my coin can flip 0. Okay, now, let me ask you guys this question. If I flip my coin 100 times, do you think my coin will get closer or further away from 50%? Closer or further? Think about this before you answer. Is my answer going to get further away or closer to 50%? It's not going to be unpredictable now. You're going to flip your coin 100 times. It's definitely going to be closer. It might not be 50%. If it is 50%, you're very lucky that it will get there. But it won't be the same as if I only throw my coin 2 times. If I throw my coin twice, the chances of me landing close to 50%, not very high. But if I throw my coin 100 times, then the chances of me getting closer to 50%, very high. What do you guys think would happen if I flip my coin 1,000 times? What are my chances of me getting closer to 50%? Further or closer? A lot closer, yes. Goes closer, yes. Closer, yes. Correct. My chances get closer. So while you're answering the PACE poll, we're going to look at these 3 questions very quickly. It says here, what is the relevant frequency or the relative frequency according to your coin of heads? So the relative frequency for me, my frequency was 4/10. I want you guys to tell me what was the relative frequency of your coin for heads. Tell me in the chat. What did you guys get for heads? Okay, Danvir says, Namithile says 5 out of 10. Danvir says 6 out of 10, 6 out of 10. Pascal, how did you get 7,5? I need to know how we got 7,5 because you either flipped it or you didn't. I don't know how we get 7,5. Right. So you will note that your answer is either on the mark or it's going to be just a little bit off. Okay. It's just going to be a little bit off. Now, what is your relative frequency for tails? My relative frequency for tails was 6. over 10, right? Oh, Mangibonge's one was 1 over 10, which means Mangibonge had heads 9 times. Okay, obviously for Tiana, same as the first one because it was 5 over 10, right? But for some of us, it's not going to look the same, right? Now, the question says, do these results match the theoretical probability you were expecting? Did they come out the same as your prediction? For most of us, it's going to be no. For the few lucky ones who got 5 for each, the answer will be yes. But for most of us, the answer will be no. Right. And that is the difference between your theoretical frequency, now I'm saying theoretical frequency, theoretical probability and your relative frequency. Okay, give me a thumbs up while you answer Teacher Nell's poll. Give me a thumbs up if the difference between relative probability, Teacher Coco, your English is definitely gone. Give me a thumbs up if you understand the difference between theoretical probability and relative frequency. Are we okay with this? Remember, guys, theoretical probability is what we think or what we predict is going to happen, not what actually happens. Because once we do something, then it happens or it doesn't. And the more times we do it, the more likely we are to get back to our theoretical probability, right? So that's the few things we take away from today's lesson. Theoretical probability, what we predict is going to happen. Relative frequency, the more we do something, the closer it gets to our theoretical probability. Okay, and we are completely out of time.